Hi, this is Europa in a nutshell. Europa is the smallest of the 4 large moons of Jupiter, and it is the smoothest object of the 7 large moons. It's a very large, smooth, spherical object, which is pretty unusual. The reason is that any cratering that has happened or mountain building that has happened on the surface has been eroded away because of internal heating on Europa due to the tides of Jupiter. So Europa is affected by the tides of Jupiter, not as much as Io, in which rock is turned to liquid and lava flows and all of the ice is melted. We have ice, we don't have lava flows here, but we do have a very dynamic surface that changes very often and a lot of internal heating, as we see. So it's significantly smaller than Ganymede and Callisto, but we can keep in mind that other than the Sun, it's the 14th largest object in the solar system. And it's made primarily of ice and rock, with the rock down deep and maybe some iron core and ice mostly on the surface. So if we look at the moons of Jupiter taken from Earth with a small telescope, we see Jupiter and they orbit Io. Io is here, Europa is here, Ganymede and Callisto is the furthest out. And these moons orbit with just periods of just from a couple of days to a couple of weeks. If we look at the 7 large moons of the solar system, one thing we can see is that Europa is about the size of the moon and Io. And there's also a little bit smaller moon of Neptune, which is called Triton. Not quite as big as the larger moons Callisto, Titan, and Ganymede. And we can see that they do have a variety of different appearances and a variety of different processes causing those, from the atmosphere on Titan, the volcanoes on Io, and with Europa we have the smoothest of all of these surfaces, with a pure ice surface with, as we can see, other kinds of colored material on the surface. Now, Io, Europa, and Ganymede are in a resonance. It takes about 1.88 days for Io to orbit one time, twice that long for Europa, a little bit less than 4 days, and Ganymede is 4 times as long as Io, or twice as long as Europa's orbit. So this is a closer up view of Europa, showing the icy surface. There really are no visible craters, and but there's a lot of this dirt-looking kind of silicate, possibly magnesium materials there. And if we look closer, we can see that Europa's curious marks. We have these very straight lines that almost look like paths, or what it reminds me of is a cue ball that you play billiards with, very smooth, but that's very old and has been marked up and scratched up over a long period of use. And so it's very smooth, but it has these dark streaks all over it. Looking up even closer, we can see very complicated patterns, but we don't see the cratering. What's happened is the melting of the ice. This is a very icy surface, and this is some darker materials that work their way up probably through the cracks that we see here. And the surface changes and melts there's probably almost very likely that this layer of ice is fairly thin, and that below that there's an ocean of liquid salt water just maybe a few miles below the surface. And we see surface changes here that would indicate that that is the case, and other reasons. Specifically, Europa has probably an iron core and a rocky mantle, and this water ocean that has probably a saltwater ocean and this icy crust with these lines and markings all over the surface. Now, we have an ice layer followed by water, followed by some kind of more silicate or sort of rocky kind of material below that. And because of that, some of this material may be mixing up and be causing these orange kinds of marks at the surface. What's very interesting is that the other thing is we know that there must be some sort of conducting fluid here, because Europa has a magnetic field. And Europa also has a very thin oxygen atmosphere, like Ganymede, caused by the evaporation, are basically ultraviolet light breaking apart ice molecules on the surface, separating oxygen and hydrogen. The hydrogen is a very light molecule and will escape. The oxygen will stay in the atmosphere of Europa, at least for some time. And so here we have a place that is very similar in some respects to a place we have here on Earth, which is, on Earth we have the North Pole, which is an ice-covered sheet that below has an ocean of salt water, and we know that's teeming with life underneath. And so it really is an interesting question. Is there life in the subsurface ocean of Europa? And the answer is we don't know, but it seems to be the best candidate for life in the solar system besides Earth. And so missions have also even been planned to go and melt through the layer of ice into the ocean and find out what is there in that ocean below that surface layer of ice. So that is Europa in a nutshell.